Can everyone see my screen and hear my voice?
Yeah.
Cool. So as I hope you are aware, you have an exam coming up on Friday. So if you guys have any quick questions about that, you can ask them now. Otherwise, the plan is to go through the worksheet here and then switch over to the exam 1 review. And I'm actually going to pick up with question 7 and then loop around. And if you guys want to see the how to do questions 1 through 6, they are already posted to the YouTube channel that you guys have at the end of my previous lecture, my yesterday lecture. Does that sound good to everybody? Cool. So find the derivative of each of these functions. So what rule am I going to use for 1a?
Product.
Exactly. So what is the product rule? The first times derivative of FOIL is not quite FOIL. It does kind of look similar to FOIL, but it's not quite. So it's the first times the derivative of the second plus second times the derivative of the first. So in this case, the first is 2x minus 3. And then I look at the second one. So, and then what's the derivative of this guy? That's going to be, this is the same thing as saying x to the 1/2 plus x. So that goes to 1/2 x to the negative 1/2 plus 1. So plus 1. And then that's plus the second times the derivative of the first. So the second is just root x plus x. And then the derivative of the first is just going to be 2. Derivative of this guy is just 2. Does that make sense to everybody? Okay, so what am I going to do for B? How am I going to get that one? How am I going to do that one?
You would need the product and the quotient rule.
Yeah, exactly. I have to do the product rule and then the quotient rule. So if the product rule for the top, so it's first, that's 2x squared plus 3 times the derivative of the second. The derivative of the second is just 5 plus the second, so that's 5x plus 2 times the derivative of the first, so that's 4x. So that's the derivative of the top. And now what's the quotient rule? It's going to be bottom times top prime minus top times bottom prime all over bottom squared, right? So if I do this guy, if I do that here, then it's going to be x, or 6x minus 7, so that's the bottom. And then I'm just going to put this here to save us a lot of time and space, because it's the bottom times the derivative of the top, and that guy up there is the derivative of the top, plus the top, so that's the 2x squared plus 3 times 5x plus 2, all times the derivative of the bottom, which is just 6. Sorry, this should be minus, and then 6x minus 7 squared. Does that make sense to people? Yay, nay?
Yeah.
Cool. So find the equation of the tangent line. F of x is equal to x over x minus 1 at x equals 2. Equation of a tangent line, what do I need? What do I need for the equation of a tangent line?
Derivative.
And? Someone other than Kat?
The y value.
Yeah, exactly. So the derivative gives me the slope, and then I just also need a point. So I'm just gonna have to find the y value to get that. So the point would be 2 comma f of 2. And that's going to be 2 comma 2, because that's 2 divided by 2 minus 1 is 2. And then the slope, I'm going to have to find what the derivative of f of x is. So that's going to be the quotient rule, right? So I'm going to have x minus 1 squared on bottom, and then the top I'm going to have the bottom, so x minus 1 times the derivative of the top, which is just 1, minus the top, so that's just x, times the derivative of the bottom, which is just 1. So that all cancels out to give you negative 1 over x minus 1 all squared. So when I plug in f prime of 2, that just gives me negative 1 as my slope. So then I just plug in y minus 2 is equal to negative x minus 2. And that all comes together to give you, so that means that y is equal to negative x plus 4, yeah. So plus 2 is equal to 4. Cool. Does that make sense to everybody?
Yeah.
Good. So assume the total number in millions of bacteria present in the culture, in a culture at a certain time t is given by n of t is equal to 3t times t minus 10 squared plus 40. We have to find the derivative n of t. This is going to be, this guy right here is kind of an incredibly boring chain rule, and then we have a product rule. So n prime of t is going to be equal to first times derivative of the second, so that's 3t, times the derivative of the second is going to be the derivative of the inside is 1 times 2 from the power rule times t minus 10. And then plus the derivative, or plus the second times the derivative of the first. So the derivative of the first is just 3, and then we have t minus 10 squared, and then the 40 goes to 0. So that is basically how you're going to write this. You might want to just simplify this guy into 6t, but in general, you don't have to do much simplification on these problems. And then I want to find the rate of the population, or rate at which the population is changing after 8 and 11 hours respectively. And that's just computation. I suspect you guys are probably just going to plug that into your calculators. But the answer here is going to be negative 84. And at 11, that it's going to be 69. So that just means that the population at t equals 8, so after 8 hours, is decreasing at a rate of 84 million per hour, and that it is increasing at a rate of 69 million per hour after 11 hours. Does that make sense to everybody? Cool.
Yes, it does.
Good. So find the derivative of y is equal to 2x to the third plus 9x all to the fifth. What do you guys think I'm going to do here?
Chain rule.
Exactly. So what's the derivative of the inside here? Derivative of the inside is just going to be a power rule, right? So 2 times 3 times x squared. So it's 6x squared plus 9. It's the derivative of the inside. And then this guy goes down, so I multiply by 5. And then I'm multiplying by this to the 1 reduced power now. So I'm just going to write that up here so it doesn't overlap with the writing. But does that make sense to people? Sometimes people find the chain rule pretty weird, but okay. So find the equation of the line tangent to the graph. F of x is equal to x, or the square root of x to the fourth minus 12 at x is equal to 2. So that guy is same thing that we had to do before. We have to get the, if we want to find the tangent line, we have to get two things. We need to find the derivative, which gives us the slope, and we need a point, because if we have a point and the slope, we have enough information to find the line. So we just do the derivative of, or first let's find the point. So 2 comma f of 2 is going to be equal to 2. And then I plug in 2 to the fourth is 16 minus 12 is 4. Square root of 4 is 2. So again, it's actually the same value we had on the other one. So 2, 2. And then this guy, we're going to do the derivative of that. And what rule am I going to use here?
The chain rule.
Exactly. Does someone want to tell me how to do this?
So you would get rid of the square root and put it to the 1/2.
Sure. Good.
And then you would bring the 1/2 to the front and then subtract from 1. That would be negative 1/2. And then multiply it by the derivative of the inside, which is 4x to the third.
Exactly. Thank you. So this guy right here provides me with the derivative is the general derivative. And now I just plug in f prime of 2. It's going to be equal to 1/2 times this guy is also going to be 1/2. That basically it's just the flip of f of 2 times 4. So this cancels with these guys. And then I have x to the third, so that's times 8. So f prime of 2 is equal to 8. And now I have my point and my slope. So now I find my line. So y is equal to, so y minus 2 is equal to 8 times x minus 2. And then I have y is equal to 8x minus 16 plus 2 equal to 8x plus 14. Sorry, minus 14. Does that make sense to everyone?
I have a quick question.
Sure.
So I understand that it says x equals 2, and that's why you got that one, but where'd you get the other two, like in the point where it says 2 comma 2?
If you plug in f of x, f of 2, then you get the square root of 2 to the fourth minus, not 24, 2 to the fourth minus 12 is equal to the square root of 16 minus 12 is equal to square root of 4 is equal to 2.
Okay, so you don't do the derivative yet. You just plug it in. Like
Yeah,
in,
when you find the slope of the original line, or when you find the point for the tangent line, you do that in the original f, not in the derivative.
okay, thank you.
Cool, no problem. Anything else? Cool. So find the values where find the values of x where the tangent line is horizontal for f of x is equal to the square root of x cubed minus 6x squared plus 9x plus 1. So here we're just going to, so what does it mean if the tangent line is horizontal? What is the slope of a horizontal line?
0.
Exactly. So that means that if the slope is 0, that means that the derivative is 0, right? So we just want to find the x's such that f prime of x is equal to 0. That's what this question is asking us to do. So let's start off by just finding out what f prime of x is generally. So we get f prime of x is going to be equal to, I'm sure you guys have noticed a pattern at this point. What am I going to use here?
See?
Yeah, exactly, the chain rule. So this guy, I'm also just going to rewrite it as x cubed minus 6x squared plus 9x plus 1 all to the 1/2. So then I do the derivative of the inside here, and that's going to be equal to 3x squared minus 12x plus 9. And then I have times 1/2, and then times this guy to the negative 1/2, because it's 1/2 minus 1. Cubed minus 6x 1 to the negative 1/2. So this right here, this is never going to be equal to 0, because it's actually it's a fraction with a 1 on top. You can think of it as 1 over the square root of x cubed minus 6x squared plus 9x plus 1. And when is this thing right here going to be equal to 0? It's never going to be equal to 0, right? Because the thing on top is just a 1, and that's never going to be equal to 0. And you would need the bottom to be equal to positive or negative infinity, which you're never going to get, not for any real number, right? So that means that we don't really have to worry about this part of it when we're trying to find where f prime of x is equal to 0. Also, 1/2 isn't going to affect things. So what I really care about is when 3x squared minus 12x plus 9 is equal to 0. When is that equal to 0? So first thing I'm going to do, I'm going to pull out a 3 from both of these sides, and that's just going to give me minus 4 minus or plus 3 is equal to 0. That guy. And how am I going to factor this? So I need two things that multiply to give me 3 and add to give me negative 4. So that's going to be x minus 3 and x minus 1, right? So that tells me x is equal to 3 or x is equal to 1. And those are the only 2 points where the tangent line of f of x is going to be horizontal. Does that make sense to people? Yay, nay?
Yeah.
Cool. So a certain truck depreciates according to the formula v of t is equal to 62,500 over 1 plus 0.2t plus 0.1t squared, where v of t is the value of the truck in dollars and t is the time measured in years, and t equals 0 represents the time of the purchase in years. So find the rate at which the value of the truck is changing after 3 years. Interpret your answer. So this guy right here, I'm just going to, this is basically a quotient rule. You can also, so one thing to keep in mind is if you don't want to do a quotient rule, you never have to do a quotient rule. You can always bring up the bottom. So this is equal to 62,500 times 1 plus 2t plus 0.1t squared to the negative 1. I think that's just a different way to write it. And at that point, you don't have to do the quotient rule. So do people want me to run through this how I just showed you, avoiding the quotient rule, or do you want me to use the quotient rule?
Avoiding it.
Avoiding it? Okay. Yeah. I think a lot of people like to avoid the quotient rule just so you don't have to memorize it. So the derivative of the inside here is just going to be 0.2 plus 2 times 0.1 t, right? And then the outside is, so this becomes times negative 1 from this guy, and then it goes down by a power. So then I'm left with 1 plus 0.2 t plus 0.1 t squared, all to the negative 2. And then I also have this constant out front from the whole, this whole time. So that's times 62. I'll just put it over here. Times 62,500 right over where it's actually printed. And that gives you that right there is equal to the derivative of t. Does that make sense to people? So, cool. So unless the problem actually tells you you must use the quotient rule here, you can always get away with avoiding it by using this trick somehow. And then you might have to do something like a double product rule or something like that, or a chain rule, an extra chain rule or something. But if you really want to, you can generally avoid using the quotient rule. So now I just plug in v prime of 3, and you guys can do that yourselves. I trust your ability to plug it into the calculator, but you get negative 8,000. And that just means that after 3 years, the truck is decreasing at a rate of about $8,000 per year. Does that make sense to everyone?
Yeah, that makes sense.
Cool. Does anyone have any last questions about this worksheet before I switch over to the exam 1 review?
Are both of these going to be on the dashboard or Blackboard? Sorry.
What do you mean are both of these? So
like the worksheet itself.
Oh yeah, I didn't post them to the Blackboard. If you just Google Drexel Math 102 Winter 2021, this page has all of them.
Oh, okay, thank you.
Yeah, no problem. And then it also has the practice problems for the exam.
Okay, thank you.
So does anyone have any specific questions that they want me to go over on the exam 1 review if you've looked at it? If not, like I said, I'm going to pick up actually at problem 7 and then loop around. Okay, cool. So use the definition of f of x to answer the question or to find the requested quantity. So what is f of 2 here? Well, I just look at how it's defined. So it's defined here between 1 and 5 inclusive, and that's where that's where 2 is. So when I want to find f of 2, I just plug in 2 to this. So this is going to be equal to 2 squared minus 6 times 2 plus 5. It's going to be equal to -3. Cool. So the limit as f of x approaches 1, then for this one I have to check, does the right-hand limit agree with the left-hand limit? The right-hand limit is just going to be, so the limit as x approaches 1 from the positive side of f of x is going to be equal to 1 squared minus 6 times 1 plus 5. So that's going to be equal to 0. That's sigma. And then the limit as x approaches 1 from the negative side of f of x is equal to 2. So what does that tell me about the limit as x approaches 1? What does it mean if I have a different left limit and right limit?
The limit doesn't exist.
Exactly. So the limit there does not exist. And then what about the third one? I'm just going to make some more space. So D and E, and then we got 0 for this one, or is it? No, -3. Yeah. Yeah, -3. And then this guy, so the limit as x approaches 5 from the positive side is equal to this definition. So that's going to be equal to negative x. So -5 plus 5 is equal to 0. And then the limit as x approaches 5 from the negative direction is going to be equal to what I get when I plug 5 into this definition. So that's going to be 5 squared minus 6 times 5 plus 5. So that's also going to be equal to 0. So if the left hand and the right hand agree, then that tells me that the limit is equal to whatever they agree on, so 0. Does that make sense to people? So how does this, what information does this give me about the continuity of f in general? Can you guys point to give me any points that this tells me f is discontinuous?
At 1.
Yeah, exactly. Because the limit does not exist. And you guys actually have a couple of other, you guys have like a list of criterion and it's numbered, but it's good to just say like the limit does not exist. Everywhere else it's going to be continuous because this inside function is continuous everywhere, this function is continuous everywhere, and this function is continuous everywhere. So that tells me that the only points of potential discontinuity are on the boundaries where it switches definitions. And we checked both boundaries, only one of them has an issue. Does that make sense to everybody? Cool. So use the graph f to find the requested values. So f of 1, I just scroll over to the value 1 and then up, and then I see that it is equal to 2. Similarly with f of 3, I go over and then I go up and I see that this is equal to 4. Then the limit is a little bit more complicated, but I check OK as I'm going from the right-hand side, it's approaching 2. Then I go, sorry, from the right-hand side, it's approaching 2, and also from the left-hand side, it's approaching 2. So it's equal to 2. And we can see, OK, at this point it's continuous. And then we do the same operation as I approach from the left-hand side. I'm approaching 4, but wait, as I approach from the right-hand side, from the positive side, I'm getting not 4, but 2. So here, the limit does not exist. Does that make sense?
Yep.
Cool. So I want to identify the intervals where each of these functions is continuous. Where is e to the x plus 1 continuous? So is what values, what real values can I validly plug in to e to the x? Or any exponential?
All real values?
Exactly. And if I just shift over that exponent by 1, it's going to be the same thing. So this function is continuous everywhere. So negative infinity to positive infinity. Does that make sense to people? Cool. So we get something similar going on here. It's just a rule I've mentioned a few times. Polynomials are continuous everywhere. We can plug in any value into a polynomial and we'll get a real valid value out. So there we go. What about this guy? What is going to break him? So x equals 8 does break him, and the reason x equals 8 breaks him is because then we're divided by 0. So when you're checking for continuity and there's something on the bottom, you always have to check where that is equal to 0. So this is discontinuous when x squared minus 64 is equal to 0. And that happens when x, so this can be factored into x minus 8 and x plus 8. It's the difference of 2 squares. So that's equal to 0. And this happens at x equals 8. This happens at x equals negative 8. Cool. So it's discontinuous there, which means it's continuous where, so we'll do negative infinity to 8, negative 8, 8, negative 8 to 8, and 8 to positive infinity. So that's a lot of 8s and sideways 8s, but that is, I should draw that U in between them because it is the unit of those sets. Does this make sense to everybody? Cool. Okay, so what values am I allowed to plug in to the natural logarithm function? So the natural log is the inverse function of e to the x, right? So I'm only allowed to plug in values into the natural log that can be gotten by e to the x. What values can e to the x hit?
All real values?
Not all real values. It can take all real values,
No.
but it can't hit all real values. What value would I have to plug into e to the x to get -73? I can't. It's impossible. I can't get a negative number, and I also can't get 0 because I would have to plug in e to the negative infinity to get 0. So e to the x can only take positive values, which tells me that e to the x can only spit out positive values. It can take any real value, but it can only spit out positive values. So that tells me ln can only take in positive values. So that tells me that 3 minus 8x has to be greater than 0. So if I just rearrange this, I get 3 is greater than 8x, and then 3 over 8 is greater than x. So this is where it is continuous. So that's 3 over 8 to infinity, and that's not inclusive because this guy cannot take in 0. ln cannot take in 0. Does that make sense to people? Yes, no? Okay.
Yeah.
Cool. So differentiate each function below, do not simplify, is actually easier for us to grade and easier for you to do if you do not simplify. So what am I doing for the first one? First one's just a really boring chain rule because the derivative of the inside is just 1. So I get 1 times 2 times t minus 10. And now that's to the 1. So that's just 2t to the 10. Similar idea here, but now we have a product rule as well. So the first times the derivative of the second is 3t times 2 times t minus 10 is equal, plus the second times the derivative of the first. So this is the second. The derivative of the first is just 3. 3 times t minus 10 all squared. And I think we actually did this exact thing in worksheet 4 just now. But that's all you need. This I wouldn't dock you because it doesn't say simplify, but I would also say that it's probably just easier to read if you do 16 instead. But like I said, this is perfectly fine. In fact, that's actually the top thing is what the answer key says for this one, and I'm pretty sure that the 6t is what the answer key says for worksheet 4. So either is fine.
So differentiate basically just means find the derivative.
Yes, yeah, that's exactly what it means.
Okay.
Cool. Yeah. Cool. Yeah, sorry. Sometimes we can just throw all the vocabulary at you guys at once and expect you to put it all together, but yeah, exactly. So this guy right here is going to be like I said before, you can always get away without using the quotient rule, but I think that it makes sense for us to do the quotient rule here. So this is going to be bottom times the derivative of the top. So this is bottom. The derivative of the top is going to just be 1/2 w to the negative 1/2, because that's the derivative of the square root of w, and then the 17 disappears. and then minus the top times the derivative of the bottom. So the top is the square root of w minus 17 times the derivative of the bottom, which is going to be 3w squared. And then that's all over w cubed plus 15 all squared. Does that make sense to people? Cool. And now this guy right here is just going to be a product rule. That's going to be the easiest way to do it. But first, I'm going to convert these guys into, so this is w to the 1/5 minus 17 to the w to the 1/2. That's all times w to the 3/4 plus 15 w to the 1/3. Cool. And now I can just do the derivative of this guy. So first times derivative of the second, b prime of w. First times derivative of the second, so that's w to the 1/5 plus minus 17 w to the 1/2. All times this guy becomes 3/4 w to the negative 1/4 plus 15 times 1/3 w to the negative 2/3, and then plus the second times the derivative of the first, so that's w to the 3/4 plus 15 w to the 1/3 times the derivative of this guy, so that's 1/5 w to the negative 4/5 minus 17/2 w to the negative 1/2. I'm minus 17/2 w to the negative 1/2. Does that make sense to people? It's a bit long and messy, but like there's a lot of individual steps, but I don't think any of the individual steps should be too hard for you guys. It's just the changing to the exponent form, simple power rule, and product rule. Cool. Now assume that the total number in millions of bacteria present in the, so this is, we just did this before, right, in the worksheet 4, so I'm not gonna bother going through the whole process, but it's just, this is going to be the, yeah, so actually we literally just did this problem on worksheet 4, so I won't bother going through it, but you can check the recording for what we did earlier. Does that make so? Do people have any specific question? There's only 6 minutes left of these first 6 that they want me to go over. If not, then I'm going to just go through them in order until I run out of time. Cool. I will just go through them in order until I run out of time then. So here we have to plug it into the limit definition of the derivative, and that's going to be a little bit time consuming, but shouldn't be too hard computationally. So it goes to 0 of negative 15 times x plus h squared minus 6 times x plus h minus 12, and it's minus so got right there, limit, and then we get 15x squared minus 30xh minus 15h squared minus 6x minus 6h minus 12. Then we get plus 15 squared plus 6x plus 12 all over h. What cancels?
$15x squared, 12, 6x.
Beautiful. Exactly. And then I am left with the limit as h goes to 0 of 30x h minus 15h squared minus 6h all over h. So I can cancel these h's too now. And I get the limit as h goes to 0 of 30x minus 15h minus 6. What happens as h goes to 0?
$30x minus 6.
Exactly. This guy disappears, and we're just left with 30x minus 6. Does that make sense to everybody? If they ask you to use the definition of the derivative, then you have to use the limit definition. You can't just use the rules that you have. Even though if you were just to use the power rule, you would be able to do this much quicker, right? So now I'm just going to do the same thing for this guy, and it'll be a little bit more complicated, but not too bad either. So that becomes 9 over x plus h, right? Because that's just what f of x plus h is, minus 9 over x, and that's all over h. I'm actually just going to rewrite this as 9x plus h minus 9h, and then x, and then just multiply this whole thing by 1 over h. I think that will make things easier to see in a minute. But in the meantime, I'm going to multiply this guy by x plus h over x plus h, and this guy by x over x. So that gives me 9x divided by x times x plus h minus 9x minus 9. So yeah, I'm gonna put this all on the single. No, I won't skip the step. Minus 9 over x. Sorry, this is a bit messy. Let me erase this and clarify it. All times 1 over h. So now I can combine these guys, and these guys cancel, and I'm just left with negative 9h, right? Because this is a minus, so it distributes, and then I'm going to push this 1 over h into the denominator too. So that gives me h times x plus h. These h's cancel, and I'm left with the limit as h goes to 0 of negative 9 over x times x plus h. But as h goes to 0, this just becomes x. So this is equal to negative 9 over x squared. Does that make sense to everybody? Okay, I don't have time to do another problem, so you guys are free to go. Good luck on your exam on Friday.
Thank you.
Thank you.
Thank you.
Nice.
Do you guys have a question, or are you just signed in but not actually present? Cool. Have a good one.